I've been programming every single day for 365 days. So basically a year. Well, actually, I've been programming for 409%.
By the way, you're gay.
409 days. So over the last year, I've been programming / writing code, and if not doing that, studying anything related to coding / programming or protocols of which I could use inside my programs. And it's been a fun ass journey. I'm not gonna lie, it's been fun. It's crazy that a year already went by. I remember making my first video like it was yesterday, but I'm gonna show you what I made so far. I'm not gonna show all my projects because like it's so many, I don't have that much time, but I'm gonna show you guys the latest projects, the most recent ones I've been working on, and how far I've been going with them, and where I'm at with them, and what I'm gonna do moving forward. Y'all finna see. And I also got some videos like 2026. I'm gonna tighten up when it comes to uploading videos. So I've been uploading videos for like one video like every 2-3 months, and like I'm really slacking when it comes to that. It's just like I don't want to make videos about something of which I don't have a certain amount of knowledge to which I can explain something in a way of which people can retain when they hear it come out my mouth. So that's why it's like I've been waiting a little minute. I've been holding off on making videos, but next year I have a lot of projects, a lot of information, a lot of things that I've built upon and learned. So I am gonna be showcasing more shit next year. But until then, let's go ahead and get into the video and show y'all boys that I've been working on though. Alright, y'all finna see real life greatness, man. So we finna go ahead and load the program. Let's tap enter.
Welcome to NetAlert 3.0, our intrusion prevention system developed by NSM Bari.
Alright, so we put in our iFace, our subnet, local IP, and then we do CLI mode.
Starting.
And now it's gonna scan all the devices on the network. It's gonna send ARP requests to all the devices on our network. It's going to find them, and it's gonna create a separate thread for each device. It's also gonna do a web server. So we're gonna go to the web server right now to see the front end view of it. So here's what it looked like. So look, we got the IP address, the host name, the MAC address, the vendor, and then we have the status of each device too. And then we got the network uptime, the amount of nodes found, the amount of nodes online. And that's not even the coolest part, bro. Look. All right, boom. So we got my laptop right here, right? Oh no, my laptop disconnected from the internet. Whatever will I do? How will I know it's offline? Like it's supposed to be online.
Laptop is now offline.
Type. Y'all hear that? Laptop is now offline. And if we scroll down here,
Azure Wave Technology
shows the laptop is
now
offline.
offline.
All right, look. Go ahead and turn this bitch on. And we're gonna turn the Wi-Fi back on for it. Boom, connect back.
Laptop is now online.
Then if we come right here now, it shows the laptop is now back online. All right, y'all niggas thought y'all seeing some cool shit, bro. Watch this, watch this. Yoda, attack.
Yes, sir. Yoda now launching attack.
Y'all see this shit over here, bro? Broadcast storm going on right now. So it's basically underneath an ARP poison attack for each device within the network. And you see how we got the IP address and the MAC address of each device. They're now all within a separate thread going through a loop. And that's really how it works. Now I can also select to stop. Yoda, stop.
What the fuck wrong with you? I'm on that good cushion alcohol.
Yoda, stop. It was supposed to speak out through the thing that it stopped to.
Samsung Electronics Company Limited is now offline.
Yeah, I don't know why I didn't speak saying that it stopped. Oh, I got an error. Yeah, I still got some shit to work out through. So the point of that project is to have an intrusion detection / prevention system that has all my network traffic, or at least that specific node traffic, flowing through an AI model. That AI model then regulates, analyzes, and guides that traffic and tells me whether or not the traffic is malicious or if it's safe. And that's really the main purpose of it. I also have a module that's specifically for sniffing the traffic from your network and parsing it through what specific protocol it is the port is using, where it's going to, source and destination, and then it goes through the AI model, and then it's also stored in a SQL database. That portion of the program is kind of on pause right now because of the fact that to run a local LLM, I need something stronger than a Raspberry Pi 5, and that's what I just had the program running on. So until then, that part's gonna be on pause, and I'm gonna come back to this program probably within like a month or two. I'll work on this program for like 2-3 days, hard to sell, you know, a couple hundred lines of code, tear down some shit, reconstruct some shit, and then I come back to it a month or two later. You know what I'm saying? Because it's gonna take some time to perfect this. So I mean, that's how I'm moving with it. But we're gonna go to the next program though. All right, this is one of my other programs. It's called NetCracker, and what this program is, it's supposed to be a Wi-Fi hacking suite that has a bunch of different tools or methods ranging from wireless passive sniffing recon methods to more aggressive things like an evil twin attack, a deauthentication attack, and also to be able to do a beacon flood and capture and crack handshakes. Now, the capture and crack handshakes, it works. I just don't have it to where it automatically allows you to pass it to Hashcat, which then allows you to, from there, brute force the hash itself. But it's able to capture handshakes. The beacon, I have the beacon flood too, but I'm gonna branch off the beacon flood and put it into its own option to where it's an evil twin attack, so that way you could spoof another SSID and kick the real SSID clients off of theirs, so that way they could connect to yours, and it's gonna pop up a captive portal, and they're gonna try and sign in with user credentials, and then it goes back to you, and now you have their shit. Now this is all illegal, bro. This is really all illegal, but you know, you gotta practice your craft some way, somehow. You know, I'm not trying to do no illegal shit, but you know what I'm saying, you gotta learn what the bad guys do some way, somehow. You know what I'm saying? So we're gonna go to the first mode. All right, before I even continue going, you're gonna need a Wi-Fi adapter if you're gonna want to do any type of Wi-Fi hacking, bro. Any type of Wi-Fi, you need a Wi-Fi adapter, and you're gonna need one that can go on monitor mode. And I got the alpha. I got off of Amazon. If y'all boys want to check it out, I'm gonna put a link for this in the description, because people be asking me where I be getting it from, and so I'm gonna just put a link in the description so y'all know where to get it from. All right, so this right here, this is what you use in something called ward drive. If you don't know what ward driving is, it's basically you doing recon while you're inside of a car with any type of device that allows you to capture and save Wi-Fi networks, and along those Wi-Fi networks, you're also storing the channel, the encryption type, the BSSID, and the SSID along with it, and the signal, and also the longitude and latitude of where that, basically where that network's at. So I'm gonna go to show you guys what it looks like so far. All right, so right now it's finding all the access points within my area. These are all the access points that are around me right now, and it's getting the vendor, the signal, and the SSID for each one, and the BSSID, and it's storing it all within the JSON file. Now, you will use something like Kismet if you're gonna do this within the actual reality, and plan on uploading it to something like wiggle.net, which is a crowdsourced website that allows you to push Wi-Fi networks along with the information, like the metadata that you find with it. And then I also made a stationary mode for if you want to track the MAC addresses around you that are not access points. So here are all the devices around me that are not access points. And anytime they make a probe request, I also capture that and can view and see where a user has been based on the type of devices that their phone is probing, which is a very useful thing. All right, bro, this is one of my favorite parts, low key. Like on some recon shit, is one of my favorite parts. So this module, this specific method is called client sniffer, right? So basically, it's gonna scan for all the SSIDs within the area. After it finds a specific SSID, you could choose which one you want. Or after it scans all the SSIDs, you could choose which one you want to target. It's gonna take that SSID, right? As you can see here, these are all the SSIDs in the area. We got 30 of them. We have the encryption type, we have the frequency, we have the channel, and the RSSI. Now, we can choose which target that we want. So I'm gonna go ahead and do me because legal. All right, so here we go. We got all the clients coming up. I had to fix a bug in my code. Like I had a crazy ass bug where I wasn't setting the channel sometimes, and I didn't realize I had that. So I had to go back and fix that, but here he is now. And these are the devices that are on my network. And as y'all seen earlier, y'all already know that I have this amount of devices on it. So this basically takes all the MAC addresses in the area. Without you even being connected to that network, you're able to sniff those MAC addresses and able to parse it and see if it's connected to the target network that you're targeting. And from there, you could tell how many devices are connected to that network without even being connected to yourself. You could then take this and you could also cross-reference it with Wireshark traffic that's crossing paths with MAC addresses, or you could go on the Bluetooth Inspector app and also view the amount of devices in the area through Bluetooth too and cross-reference BLE and Wi-Fi traffic. I'm trying to do some shit like that right now, but until then, we're finna get back to this though. And y'all already know, man, we got the beacon flood attack, which it works, but it doesn't fully work. So I'm not gonna show y'all that right now. And then we got the capture and crack handshakes, and that one allows you to capture a handshake for a specific network that you target. It's gonna send deauth packets to all the devices connected to that router, and so make them disconnect. And that way, when they reconnect, they send a hash. The router sends the hash password to the device, and we sniff that hash, and now we store that hash and we try to crack it. It's not fully done. It has most of that implements. I just got to implement hashcat so that way it's able to crack the handshake. And on top of that, we're gonna add an evil twin, which is gonna branch off of beacon flood. And then I'm also gonna add a method slash class that will allow you to crash routers by sending it an overwhelming amount of different types of frames that cause it to store fake clients on the router. So we're gonna come back to that shit though. I'm gonna give this program a break too because well, I'm gonna show you in a second. All right, now this program is an ALPR finder slash sniffer, and if you don't know what that is, it's basically Flock Safety is an organization slash private company, and they're pushing for Flock cameras. These Flock cameras are AI powered cameras, and they're basically supposed to be able to track license plates, so that way they know whether or not you're, let's say you have a missing ticket or if you haven't paid your tag or some shit. But as we know, the surveillance state, they have taken it beyond this point. So now they're using these AI powered cameras to stereotype you based off your car, to know when you're leaving your house, who you're going to, who you're going with, when you're doing it, what, when, and why. And they're also going to use it to be able to monitor you and keep an eye on what you're doing. And they're installing these on every intersection within major cities. And so I made a program that's able to find it. I was inspired to make this program from a dude named Colonel Pennant, and he's a hacker, and he made a C++ version of this, but you needed an ESP32 to run the program. So that's why I was like, it's like, I like the ESP32s, but it's like, I don't want to always have one in order to sniff Flock cameras. So I made a Python version of it, and here we are now. All right, to run the program, I'm going to do sudo virtual environment slash bin slash python slash main dot py dash I WLAN 1. And it's gonna put the adapter. We give it a monitor mode, and it's gonna use the Wi-Fi adapter along with the Bluetooth adapter built into the chip on your computer to find Flock cameras. And as you see, we already found one. Now you will get some false positives, but the chances of you getting that is actually very low because most Flock cameras advertise their BLE name as Flock Safety, or FS, and then EXT battery, because I'm gonna have a battery pack and those emit BLE signals. So I'm gonna show you guys what it looks like when it's in verbose mode, so you see how it's able to track that traffic. So we're gonna do -V. So these are all the Bluetooth devices in the area, and we're filtering through those devices to see if any of those match a specific parameter based off of SSID, a BLE MAC prefix, or a BLE name, or a UUID. So here is the logic for how it filters it. So basically we got a signatures.py, and inside of here we have Flock signatures based off the Wi-Fi SSID patterns, the MAC prefixes, and the BLE names, and we got some service UUIDs. But boom, so we come over here, we store each of these inside a constant, and then we come over here, and then we take the SSID that we got from the Wi-Fi adapter from sniffing, and then we loop through each SSID name right here. And if it equals any of those, then we know that it might be a match. Same thing for the MAC address, the BLE name, and the UUID. And then from here, this is how it prints out on the screen. So as you can see, it prints out like this: match, negative, 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 positive. That's it right here: negative, negative, negative. And this is really the code behind it. It's really nothing too crazy. This is really the best part about it. So we use the Bleak library to discover for devices. We then store it in the variable, and then we iterate through it. We get the local name, the RSI, UUIDs, manufacturer name, and then we store all that shit within a JSON file. So I actually branched off this program and created another program which is going to allow me to create a BLE sniffer, but also a BLE fuzzer. And it's also going to show me if each UUID that's on that specific device has write request, read request, write with no response. And I'm going to start heading into a direction where I'm going to start doing Bluetooth hacking, and I actually bought a lock that's BLE powered, and I'm making a program in Golang to allow me to exploit this, and I'm gonna start finding CVEs and BLEs. That's what I'm gonna try to do. I want to do hardware hacking, and BLE is a subset underneath that, you know what I'm saying? So that's what I'm gonna start doing. Now the only thing about this program is that after a while I get like a buffer overflow, some shit like that. It's like hella weird, but it's like yeah, you probably like, well, how am I getting a buffer overflow in Python? But like, I kid you not, bro. After a while, it's like as it's looping through these devices, I will just keep getting this exception error right here, and it'll return back to the main loop, and it'll still give me the exception error. I really don't understand and or know how, but I'm gonna come back to this program. Sadly, it's made in Python, and I'm trying to work with hardware level shit through Python, and you already know, some of y'all probably know how that go. It do not be going good sometimes. So I mean, I'm gonna just lead us here. But hey, but I welcome any contributors, anybody that want to help out. Please let me know. Just message me on Instagram, Discord, or just do a little pull request and let me know something though. We're gonna go to the next one though. This is a BLE sniffer that I'm making using Golang. It's gonna allow me to find all the devices in the area that's using BLE packets, and I'm gonna be able to append those to a list. I'm then gonna iterate through that list, and each device, if it has a UUID is plural, which is a service, I'm then going to iterate through those services, and I'm going to see if each characteristics that's in that service has write request, read without, or write with no response. Basically, I'm going to be able to see, depending on these characteristics, if I'm able to send frames to those devices, or not even frames, but BLE packets to those devices, and if whether I'm able to exploit them or manipulate them or fuzz them in any type of way, or do a DOS attack on it. So that's the main purpose of this program. It's gonna sniff, and it's gonna allow me to enumerate services, and then it's gonna allow me to fuzz those services. So that's really the main purpose of this project. It's gonna be a framework for Bluetooth hacking, BLE hacking. It's gonna be lit as hell. I really can't wait for it to get somewhere, but this is how I'm starting off so far. All right, so this is the code behind it. So if we come up here, we're creating our adapter right here. We're getting a default adapter. I'm gonna change this soon to where I'm able to choose the adapter that I want, because I bought a BLE adapter that has like 500 feet of range, so I'm gonna definitely be using that. We got a struct for it. So right here, we're enabling BLE. If it has an error, return. So right here, we got the local name, the address, RSSI, UUID, manif. So it's kind of like as you've seen in Python. It's actually pretty similar. But I'm doing it in Golang because of the fact that I want to be able to control the hardware on a lower level with less errors. Golang has adapted to errors in a way to which, like, if there's an error, right here, it's gonna return it right here. Like, Golang is kind of crazy when it comes to that. It's very good and it's nice. And right here, this is a thread right here. So I'm starting the BLE sniffer, and then I come down here, and after 5 seconds, I'm gonna have it stop. Now this is gonna be an argument, so I'm able to do like dash T, maybe 10 seconds, 15 seconds, but right now I'm still learning Golang. But in like a month, in like a week or two, I should have this shit. The sniffer should be done. The service enumerator should be done, or close to being done, and then from there I'm gonna just keep building up my knowledge, because Golang is way different than Python, bro. Way different than Python. So yeah, that's how we going right here from now. Now, for the last 400 days, about a year, a little over a year, I've been learning Python, a little bit of C++, and now Golang. So my year goal for next year, 2026, and 2026, is that I want to have a full-time job in tech, of which I like, you know what I'm saying? Not like some IT shit of which I don't like. You know, I don't really like IT at all, to be honest. No hate towards that, no shame, none of that. It's just not my thing, you know what I'm saying? I want to be on the hacking side of it, red teaming side, and or programming / engineering side. That is the end goal for me, of which I would want to achieve, you know what I'm saying? Or at least the mid-range goal. I was thinking about starting an LLC and maybe finding CVEs underneath that, to which that will help me stand out in a way of which I'm underneath a company with found vulnerabilities, so like legally hacking and shit like that. So that's like a path I was thinking about taking. I might actually take that too. We will see. I was thinking about joining the Space Force, but I've been kind of having a little bit of difficulty with that. So we will see coming up though. But until next time, I'm gonna see y'all boys in my next video. Hopefully when I do my next recap of programming / I guess now hacking journey, because I am now hacking. So I guess my next video next year around this time is gonna be a year of hacking. So I mean, I guess when that video come out, hopefully everything I did in this will pale in comparison to that video then in the future. But until next time, thank y'all boys. I appreciate y'all for watching, boys and girls, everybody that's been supporting me. We are at 9,000 subscribers, and when I first started this journey, I was at 800. But you understand that I gained 9,000 subscribers in a year, and I just had a bunch of love, people following me and shit like that, joining Discord, following me on LinkedIn, following me on Instagram. People give me all types of love and shit, you know. I have people of all races, white, black, brown, trying to help me out and giving me tips and tricks and advice in which I could use to better place myself in a way of which will help my future self out, you know. So I really appreciate that, everybody. But until next time, make sure y'all boys follow me on Discord, or make sure y'all boys join the Discord, follow me on Instagram, subscribe, follow me on LinkedIn, so y'all stay updated. Until next time, I'm gonna see y'all boys later though. Thank you guys for watching. Can't wait to see you guys in year 2 of programming, 1 year of hacking next year. Until next time, see y'all boys later though. Peace.
Told her I'm lonely, know I'm a gangster, I'm bringing my pistol to song. Like 50,000 in Sacone, she screaming out piss, I'm still in that car in my home. Like 40,000 in some A's, we swapping the barrel and the pistol, they couldn't even trace. Ain't swap me his gun cause I braced it. Upon me his hand and the bitch let me fuck on a spaceship. Upon me his hand and the bitch let me fuck on the airplane. I get her a flight, she gon' fly me to Murray Jane.